Hello friends, welcome to a video. In the previous video we tried to reset one of our batteries with this Arduino board. Today we are going to use another board called the FX2LP Cypress board, and this board uses the SMBusB function here, and you can find the firmware, also the software, and some variety of the softwares are available in the internet, and the link in the description box, you can check. So we are going to crack, or we are going to read some of the data from this BQ8030 chipset, and I have another batteries also, the BQ8030 and one 51F chipset. And this is a larger battery, and this one is the 4400 milliampere, and this is the 5200 milliampere. So this uses some greater protection here, and so we are going to read the EEPROM and return the or rewrite the EEPROM by editing some values. So let's check the program code and let's start the video. This is the website which we are going to use the firmware, use the softwares, and also some other useful details are all available in this website. And you can see the driver files here. The Zadig Driver Installer is used for the Windows, and no driver is needed for the Linux. And you can see some other features are talking about the Cypress board. And we need only the SCCL and SD and ground pin here, same like the Arduino board. And some useful links are given. You can check the source code, the library documentation, and the build instructions. So let's open each link, and in the build instructions you can actually find some pre-compiled Windows tools. I already used the tools to read the data from the chipset, and you can get the same from the link, and then some another link about the program and the firmware and how to make the softwares. You can see it is nearly 7 years ago, but this file is just only 2 years ago. So it is the latest update, or the update stopped before the 2 years. Then the third link, it says about some detailing and some compiling the program and how to use it and how to use the code and some other details. You can visit the link and you can check some other details. So but today we are we need some other link. So below the link you can find the some chipsets: BQ8030, R2J240, M37512, and these are some common gas gauge or the fuel gauge ICs used in the laptop batteries. So just click on the BQ8030 with the Sanyo firmware. You can see the IC here. It is the same. It is not in the same model. For in my case, it is just BQ8030A. I think this is the original one, BQ8030DBT, and it's actually comes with another chip, the BQ29330. It's actually the FE, the battery controller. Some other functions are used by the chipset. This website, the Karosium, so it's actually dealing with all the details about how to read the data from the chipset, and you can see the code and some other details. So let's connect the battery and the board. Here you can see the SDA and SCCL pin. So we need to connect the clock and the data pin and the common ground to the board. So the gap, so this is the plus, and this will be clock, and this will be data. This may be the temperature or the battery present, and these two are the ground. So we need to connect the data to this, clock to this, and the common ground. The connections are made. You can see it uses the old USB connection. So make sure if you buy to this board also by the same USB cable. And fortunately I have one old Nokia cable with me. It suits with the board. Let's connect the device to the PC. So there is a power button used to on and off the board, and I directly connected to my PC. And so let's check on the device manager. You can find the LIB USB K USB devices is found, and the Cypress FX2LP is there. So we need to install the USB files. If you don't know how to use it, you can check the same link. There is a Zadig Driver Installer is recommending. You need to install the Zadig Driver Installer. So Zadig is downloaded, and let's install the software. So this is it. Just click on the options and list all devices. You can see this is my camera and this is my mouse, and there is the SMBusB interface. Because it is showing the SMBusB, I already used the firmware. If your PC may show this as the Cypress board, so just click on it and you can see the driver installed actually on the board. So if the device is not found in the program, you need to select the correct program from the software and click on the replace driver. So it will install the USB driver to this board. If you downloaded the SMBusB version, you can find two versions, the 32-bit and 64-bit. Whichever you want, just use it. I'm using the 32-bit here. So let's go to the folder and open the command prompt, and let's drag and drop the SMBusB scan.exe and give a space and -a. So just wait. If this shows, then it is the connection is right. You don't need to check the connections, and you can see the battery is not showing. It means the battery is dead. We need to give a 12 volt or some more voltages to wake up the battery, and this battery is permanently damaged from a laptop. We need to actually give some supplies to enable the battery. Let's give it. Here you can see I connected a laptop pin. It is a DIY connector pin, and you can see there is a LED is attached. If I turn on the light, it is not turn on. It means it is not giving any output. So let's connect the 12 volt. You can see it is very low light. Let's run the code again. Now you can see it is showing the 16 and the 17. Now use the SMBusB report and just drag and drop and enter. Now you will get the details like this. It is the 2014 battery using the Sanyo firmware. It is used in the Lenovo laptop, and some other details are also mentioning the voltage, the current, the charging current, the charging voltage. You can see, and each cell voltage is very low. That is why this battery is not giving any output. I hope this will work. Let's disconnect. So it is giving a small light here. Let's read the SMBus again. Now the battery is giving the current. The voltage is not showing because we disconnected the charger. Previously it is showing us 2 ampere, which is correct, and the charging current and charging voltage. Now it is showing only 10.23 voltages only. We are not charging the battery. The full charge capacity, you can see that it is only showing 48 milliampere. Wow, it is very low. We need to reset. We need to change the batteries and reset. I am not showing in this video how to change the batteries because I don't have the same batteries with me. I need to buy the batteries, but I will show how to reset the cycle count and some other details. So let's read the data, EEPROM and the program from the chipset. If you have successfully connected the battery, you can see the battery's voltage is dropped about 1 volt. Oh, I think this battery is fully dead. Okay, it is giving some values, and let's read the temperature is also different. Okay, no problem. Now use the SMBusB BQ8030 flasher.exe. Just enter. You can see some other values, save program and some other things. Let's give some value to, I just giving some value op dot bin. Let's enter. Now it is showing the SMBus version. The P is enabled, the packet error checking is enabled, and the error communicating with the boot ROM. Chip is running the firmware. That means we need to enter the chip to enter into the boot ROM mode. Then we can only read the data. So first we need to visit the website once again and go to the BQ80 with the SANU firmware. There is a method to enter the boot ROM. In this website, he is saying he tried with the not connect pin. You can see he applied some 3.3 voltage, and then he able to enter the chipset. Then he disassembled the program, and he found some interesting things, and you can see it is the 0214 code and the 0517 code. So if we correctly enter these numbers or the hex values to the 71 and the 70 register, then it will enter the boot ROM, the boot mode. So first we need to send this value. So we need to use the another tool, the com SMBusB com.exe. Let's open the com, just enter. It will show the usage. So it says in the address there is a example here. Just write the example here. Write the bus address. It is the 16, and the command, I am going to read the 0 register. Then the read command R. If I put 2, it means it is a hexadecimal. If we put 3, it is the, I think it is the byte or the word. So it will show the error -9. It is normal, you don't need to worry about it. Let's read the 17th register. It is showing the 046E, which means the cycle count is way too large. This is the cycle count. The hexadecimal value of the cycle count is 046E. So let's read some other values. Let's read the 54. It is showing the error. If we put the 3, it will read the full byte here. You can see. Now we need to enter these commands. So first let's zoom it, then you can see. Okay, first you need to select the com, then I'm using the command W here, and you need to select the register. It is the 71, and write. So before that, just first read the value. Let's check. It is showing error. Let's read the 17. It is also showing error. Let's read 72, also showing 000, and let's read 73, also error. So we can see the values of the 71 is my error, 73 is error, 72 only shows 00, and 70 is error. Give the command to the 71. I'm selecting the 71 register and W and 0214, press enter. Now you can see it is write the command. Now read it from the 73. So you need to read it from the 73. Now you can see it is showing a code 062F. So this is the hexadecimal value. Previously it is showing error, now it is giving some value. And the third step, we need to subtract this value from the 10,000. So let's use some hexadecimal calculator. Hex calculator, you can find any calculator in the internet. Okay, now I'm going to add the 10,000 and the minus value. Then we need to put 062F and calculate, and we got the value as F9D1. Let's copy it or put the value to the which register. You need to put the value to the 71. You need to do it fast, otherwise the chip will reset and we need to start it from the beginning. So let's write what was the value. So F9D1, it is F9D1. Okay, press enter and send 0517 to 70. That is the last step. Select 70, write 0517, press enter. Now we need to read the SMBus report. Now you can see the chip is entered in the boot mode. This is what we actually need. Now let's dump the data. I'm going to use the BQ80 flasher. You can see how it is to be used. The save, for the save the chips program flash, you need to give the -p or the -p, and you need to give the file name. I'm going to give it as save program.bin and press enter. Now you can see it is reading the program flash, and you can see the boot ROM version here. So we successfully entered to the boot ROM mode, and now we are getting the program from the chips flash. Okay, it is done. Now we need to save the EEPROM file. For the EEPROM file, you need to give -e and give a name. I'm giving the name as save EEPROM.bin and press enter. So it is done, because the EEPROM is just only about 2 kilobyte file size, and if you need any other command, you can use it. And now if you want to exit the boot ROM, you need to give this command EEXE execute. Now we exited from the boot ROM. So let's read the SMBus report again. Now the chip came back to its normal state. You can see some other values here. The voltage is dropping. The battery is not holding any voltages, which is very bad for this battery. Now let's read the EEPROM file and the program file. So this software saves the program to the users and your username, and you can find the files here. Save program. The 2 KB files and the 72 KB files. We need to edit the 2 KB files, and you need to use any hex edit file edit software. I'm going to edit with the hex workshop, and you can see the values here showing the firmware name, the chemistry, and some other data. And we need some other values. If you want to change the cycle count, first I show how to read the cycle count register. It is a 17. It was 0460. So you need to find the 0460 in the hex file. Let's search, find and hex values 046E 046C and click OK. So we got the cycle count 046C. Just write it as your number, which decimal you want. I am going to give it 000A, which means the 10. Just only the values I am adding, and click on save. It will ask for the backup. Yes. Now we change the cycle count. We need to upload it to the chipset. So let's read the values again. The chip is working, so it is not going to turn off. The values are showing. Then we need to enter the boot mode again. So let's give the command again. The 710214 and the 73 you need to wear the 73. It is showing the previous value 6062F 062F. So the F9D1 is the input value to the 71 register, giving the 71 as the F9D1 and the 0517 to the 70. Yes, that's it. You want to check the chip is in the boot ROM because all the values are showing error. Now we need to dump the ROM to the chip. So I'm going to use the BQ8030 flasher files, and you can see to the flash the EEPROM you need to use this command W. So select and W, and you need to paste the, just drag and drop the EEPROM file. Okay, now you can see it is dropped, and press enter. So we need to give a confirmation. After that you need to give confirm delete and press enter. Erasing and the flashing, everything is done, and after that we need to exit from the boot ROM. Exit the boot ROM. Now read the value. So this time the cycle count is 10. So we are successfully changed the cycle count of this battery. So in this way we can change the full charge capacity and some other values. And if you plan to change the cells, then you need to reconfigure it again. You need to give the cell 0, cell 1 and cell 2 voltages, and the capacity you need to calibrate it again. So this time I'm just only showing how to change the cycle count, and you are seeing it is 0 10, and I am not going to use this battery because this battery is way too high. It is, you can see it is a cycle count was 1134, which is very high for this battery. Now it is only showing 10. This battery will work again, but it will not hold the charge because the cell is very weak. So that's it. That is how we are changed the ROM data. We are we are able to read the data, and we are able to change the data. That is how we do it with the FX2LP board. So if you are using the CP2112 board, you can change some other values also. It is a advanced level board. This tool, it's only work for very small chipset like this. It is not able to read the data from like the BQ9000. I have some BQ9000 with me. It is not giving any values. It is only showing some error values, and some if we are able to read the data, we can actually put the BQ9000 to alive it again. So this is how we reset the battery. And if you have any doubts, just comment below, and if you need the softwares or the help, just check the description box. And that's it for today. Thanks for watching. We will come with another video. Thank you.